Hello all, myself Shruti, Assistant Professor CSE BMSITM. Here I'll be explaining about the locally weighted regression. This is the agenda. What is regression? I'll be explaining about the linear regression, locally weighted regression, why do we need kernel smoothing, and what are its drawbacks. Now, what is regression? It is a statistical tool which is used to understand and quantify the relation between two or more variables. Regression basically range from a simple model to high complex equations. So the primary uses for regression in business are forecasting and optimization. So in addition to helping managers predict such things as future demand for their products, it also helps to fine tune manufacturing and delivery process. Now, for example, I've taken a simple example where we are trying to predict the price of a house. So there is a house price for a small house which is defined to be $70,000 and a huge size of a house which is $160,000. I need to find the medium size of a house, the price. So here given in an xy plane we are plotting the for all the data samples given, and based on this we can see that the given the x and y axis, so y axis we have the price and the x is the house what is been which is already been given. The price is given to be 70,000 for this, and the huge size of a house which is $160,000. Now I need to find the medium size house, what could be the price. So what we can do is, the possibility is if we draw a slope, then it is we can easily predict uh, exactly where the house could what is the price could be the medium size of a house. So this slope calculation can be done with the help of a linear regression. So the linear regression model will help you to find or calculate, will help you to find the slope, and using the slope what you can do is you are able to try or predict the in this example, particular example, we are trying to predict the price. Similarly, we are able to predict the forecast, or anything can be done, or predict the future market price. Anything can be done with the similar example. Now, so basically, as I told you, we have two things, that is, we consider two variables. One is the dependent variable and the independent variable. What happens in a dependent variable? Here we always denote y to be as a dependent variable and x as an independent variable. So as from our previous example, y is nothing but the price, and x is nothing but the house which is independent. Okay, and here this is the variable in the case of a dependent variable which we want to explain, or to we are going to forecast. And in case of an independent variable, it explains the other one. So it depends on something else. In the case of a dependent variable, the independent variable, the values are completely independent. So as I told you, in a case of a linear regression model, we'll be calculating, we have the linear regression model which is defined y is equal to, y is nothing but the dependent variable, and beta naught b1 beta 1 into x plus error term. Some error term will be there. So here what is x is the independent variable and y is the dependent variable. We are calculating beta naught, which is an intercept, and beta 1 is the x slope or the coefficient. So now what is this? Here, from according to the previous linear regression model, we have the intercept which is on 4, which is nothing but the beta naught. Similarly, beta 1 is nothing but the slope. the slope calculation. So that is nothing but we get a value for this particular slope. Y is equal to 4 plus 2x is the linear regression or the linear equation what will be calculating. Now, so for example, if the data is being distributed as a linear fashion or in the linear fashion, then it is easy to apply a linear regression model. Now, suppose if the data has been scattered in this manner, if the data are spread in this manner, which is non-linear, then the how we cannot apply a linear regression. So in order to overcome this disadvantage, we need to use locally weighted regression. So as I told you, what one of the problem with the linear regression is that it tries to fit a constant line to your data once the model is being created. So such behavior might be okay when your data follows a linear pattern and does not have much noise. However, when the data set is not linear, regression tends to underfit the training data. Now we have a locally weighted regression which helps you to elevate this problem by assigning weights to your training data. So to overcome the disadvantage of a linear regression, what we do is every time the data is being multiplied or it is being assigned with some weight, you're going to assign it with some weight to your training data. So weights here in this case, they are if they are bigger for the data points that are closer to the data and you are trying to predict, so thus it is local in the name. Now, in a locally weighted regression, it requires every entire data set every time you try to make a prediction, making it which makes it more computationally expensive compared to the linear regression. So we have to do this because every time we try to make a prediction, we are constructing a regression line that is local to the data point of our interest. So that is the reason we are trying. It is a repeated process or an iterative process where each time the whole complete data set has to be considered to make predictions and it has to be assigned the weight. Now, here in this case, for example, given a new instance x naught, the general approach in locally weighted regression is to construct an approximation hypothesis H that fits the training examples in the neighborhood surrounding x. This approximation is then used to calculate the value h of x naught, which is output as estimated target value for the query instance. Now, for this, if you have to assign a weight, then what is needed to find the weight? We know we need kernel smoothing. What is this kernel smoothing? It allows us to smooth out our point of interest x naught using nearby data point x. The kernel is usually defined by a function d is equal to a into e to the power minus dot product of x minus x naught divided by, it is supposed to be 2c square. The kernel is usually defined by a function d. So here as the whose values are decreasing as the distance between x naught and x increases. Now what we need to construct a matrix W to evaluate kernel for each training input x and the value we are trying to predict x naught. So the weight matrix is diagonal where all non-diagonal cells are 0. Now in this case, for a kernel smoothing, after finding the weight, that will be multiplied with the given x. So after kernel running in the kernel on our data set, we will essentially create a weight matrix where the weights are decreasing as the distance between x naught and x increases. Once we have the weight matrix, we can find the model parameters as follows. So after calculating that, we have the model parameter which is given to be beta is equal to x bar into w into x whole inverse x bar into w into y. So we here x bar is nothing but the transposition of the matrix X, and similarly we have the whole inverse and the y value to be predicted. So to get the prediction, we need to multiply beta with our input, that is x naught. So we have the to predict y is equal to beta into x naught. So beta is calculated as x bar into w into x, the whole inverse into x transpose into w into y. Similarly, how is W calculated? With the help of the kernel function, D is equal to A into E to the power minus dot product of x minus x naught divided by 2c square. Now in this case, what is A? A is a constant value which is considered as 1, and C is the kernel value. Now, so this is how we can predict the data which is slightly which is been you can see which is the locally the regression on the set of data points which is locally minimum. Mm. Then similarly we have the other type of graph which is being plotted based on the kernel value. So let us say if I have a kernel value which is c is equal to 0.1, then the graph is plotted, and we have the graph which is been nearing to such particular data. And similarly, if we have c is equal to 0.2, the kernel value is 0.2, then this is the graph which is being plotted. And if c is equal to 1.0, so which is denoted in the red line which is plotted, and very much similar to your linear regression, it looks like it is linearly which can be separated, it can separate the data value. Now, what is the drawback of this? So here every time, as we discuss, it need to evaluate the whole data set every time, and the computation cost is high. So due to that, the memory requirement as and when it increases, as the data set also increases, because it requires a huge number of iterations. Now let us see the code, how exactly it is considered. Now the according to this, what is the data set we have considered? We have considered the data set for a restaurant where given the bills of the restaurant, what can be the tip. So this is the data set, and from the graph what we can so here the x-axis we have the given the number of bills. Based on that, you are trying to predict the tip. Okay, so now let's see what is that. To plot the graph, we use this matplotlib, and to store the huge number of data, we are using the pandas and numpy for the numpy array. Now basically what we are doing, we are plotting the graph with respect to bill and the tip. So here we are loading the data, which is data 10.csv what we have, and mm, after loading the data, we have the bill and the tip which is stored in this bill and tip. So np1.array and np1.array of data.tip. So the bill and the data will be stored with respect to x and y axis. Now here we are adding one to the bill, so that we are storing, we need the original matrix as well as the transpose matrix, which has to be stacked up in the using this head stack. Now we have both the transpose of the bill as well as the tip. Now here what as the formula suggests, first is that we need to predict. So for y predict is nothing but we are predicting and we are applying the locally weighted regression. We are calling the function locally weighted regression. So in this, what we are doing, we are passing the parameter where x contains both the parameters. We are passing that with the mdiff and the kernel value. Here I have considered the kernel value to be 2. Now, once we call the local weight regression, so it comes to this particular function. So in this local weight regression, what we are trying to do, we are trying to first here the np1 dot shape will give you the size of that particular array, and a y predict when we are creating a matrix where the y predict values will be all initially 0. Now so what we are doing, for each time the data is being assigned with the weight. So if you have to assign the weight, we are calling the function local weight. So in this local weight, when this function is being called, we have the kernel value has to be calculated. So how the kernel smoothing is being calculated? So for kernel smoothing, we have the formula where k is the kernel value which is considered here. We have the formula. So according to the formula, d is equal to a into e to the power minus dot product of x minus x naught divided by 2c square. So what is this diff? Diff is nothing but we are finding the difference between x minus x naught. So diff is nothing but x minus x naught, and the dot product we consider it as diff into the diff transpose. So if diff is nothing but x minus x naught, how do we calculate the dot product? The dot product is nothing but diff into diff transpose. So according to the formula, the weight is being calculated np1 dot exponential of dot product divided by 2c square. So 2 into kernel is this, in c is the kernel k. Here in this k we have taken it as 2 as c square. So now in turn, the kernel function, it will return the weights to this. So we have the kernel function and the weight will be returned here, and here we have the weight local weight calculation. So every time, so it is being multiplied x into t into x dot t, sorry, that is the transpose of x multiplied with the weight into the original matrix, the whole inverse into transpose of x into weight into the transpose of the y. So this in turn, it will return the weight each time you call the local weight, and then the weight is being assigned for the every data, and finally you are trying to predict the y or y predict. So the y predict each time, so that is the reason you consider the whole data set every time, and it is being assigned with the weight to predict. So this is the graph which is being plot, and every time you are trying to find the when every time the weight is being assigned, and this is how the graph is being plotted. So you are able to plot a graph for a non-linear data in this manner. Thank you.